Okay, now, the inverse of this matrix, now what effect does this matrix have? This matrix takes half of the second row. Now, once I've got half of the second row, how can I get back to my original matrix? I can multiply by, let's see, find a good color here if I can get it out, okay? Well, if I double the second row of this matrix, I get back here, don't I? Okay, so my inverse matrix here, if I multiply this by the matrix that doubles the second row, this matrix multiplied by this matrix gets me back here. So this matrix undoes this matrix. So this matrix is the inverse of this matrix. The matrix that takes half of the second row is inverse to the matrix that doubles the second row. So right here is the inverse of this matrix. I've just rewritten it up here. Now, of course, I guess the second time I wrote it was here. But this multiplied on the left by this, it's not multiplied on the right, it's multiplied on the left by this gives me this. And also then, if I multiply this matrix by this matrix, if this is the inverse of this matrix, I should get the identity matrix. Well, you should verify that. Okay? Multiply this by this. If you don't get the identity matrix with ones in the diagonal, zeros elsewhere, it means that you did something, that either I told you something wrong or you did your multiplication wrong. Either is possible, so beware of all possibilities. Okay. Now what happened here? Okay, I added -1 times the first row to the third. And I got this. Okay, what would I do to this to get back to the matrix that I had here? Well, this is this row minus this row is this row, this matrix, minus this row. If I was to add this row of this matrix to this row, I would get back to what I had. So, let's try and figure out where to write it. I guess that's kind of obvious, but I don't really like writing it here. Okay, so to get from here to here, I multiply this matrix on the left by what to get back to this matrix. Okay? Well, again, if I add the first row of this matrix to this, I get what I started with. Okay? So, adding the first row of the identity to the third row gives me this. So the inverse of this matrix is this matrix where this -1 in the inverse is going to be a 1. Again, if you multiply this by this, you see how that works. Okay. Well, then I can get the inverse of this matrix, which is just completely analogous to what I did here. The inverse of this one is here. The inverse of this one is written here. And then the inverse of this last matrix, where I multiplied the last row by -1/5, is just the matrix where I'd multiply the last row by 5. If I take this matrix, multiply the last row by -5, I get this one. I'm not sure I said the negative there a minute ago, but this matrix is inverse to this. And I'm not going to write all these in there. So here are my inverse matrices, the 4 matrices that are inverse to these. Okay, well, I don't really have room to write this. Let me just kind of plan that out. I'm going to do that in another step. I'm going to take these inverse matrices, and what I'm going to tell you is, well, let's see. I know that this is inverse to this, so if I multiply this on the left by this, it's going to give me the identity. And the identity times all this is just all this, so this is gone. Then I multiply on the left by this one, and then I multiply on the left by this one, multiply on the left by this one. according to the scheme, and I'm just trying to figure out how to write it out. So we'll start again in just a second.